So, hello everyone, how are you? How's the weather? Have you been doing walks, jogging lately maybe, or traveled probably to your friend's house, or had back to school shopping at the mall? So, all of these activities require you to be at a certain destination, which means that you will be in a different location one way or another. With this, hi, I'm Nicole Ugto, a BS Mathematics and Science teaching student from the University of the Philippines, Tasmanias, and a module developer in Filipino Science Hub. In this module, we will delve into knowing about distance and displacement, what is its difference, and how we make sense of the two. But before anything else, at the end of this lesson, the students should be able to describe the motion of an object with regard to distance and displacement. With that said, let's go and explore. So for this pretest, to check what you already understand about the topic, let's have this short pretest about distance and displacement. You can pause the video and write your answers on your note-taking devices. All answers will be revealed at the end of this video, so stay tuned and let's go. So first question, fill in the blanks. Sandy walked to SpongeBob's house, which is 50 meters away from her house. After quite some time, Sandy went back to her house. Sandy's blank is 0 meters from her initial position. So A, distance, B, distance traveled, C, displacement, D, motion. Number 2. By looking at the diagram above, if you are from your house, what is the distance traveled by you if you go to the beach? Number 3, still using the diagram above, if you are from your house, what is your displacement if you go to the beach? Number 4, what is your total distance traveled if you go to the market from the beach? Assume that the initial position is still your house. Then number 5, what is your displacement if you went back to your house from the beach? So assume that the initial position is still your house. Now, with that said, let's go to the definition of terms that we will encounter in these lessons. So, since this is your introduction to straight line motion, we will deal with mechanics. So, when we say mechanics, this is the study of motion and the causes of motion, but we will only focus on kinematics, which is the branch of mechanics that is about the description of motion rather than the causes of motion. So when we say motion, this refers to the change in position with respect to a reference point. So later we will encounter what do we mean by reference point and what is a reference point. So this is where you assess the object. Through examples, we will know what do we mean by that. Then we will focus on distance and displacement in this lesson. So distance is the length of the path taken by the object from its initial position to its final position. Then displacement refers to the shortest distance between the object's initial and final position. So without further ado, let's now delve into distance. Okay, so again, distance, this is the length of the path taken by the object from its initial to its final position. So for example, imagine that you have to walk 10 steps from your house to the store. So after arriving at the store, your position then is 10 steps away from your house. Okay? Then therefore, that is your distance from your house. And that your house is the reference point. Additionally, when you, for example, already have bought what you need to buy from the store and you have to go back to your house, then we have to take note that going to the sari-sari store, that is 10 steps already, but going back to your house, that is another 10 steps. So when we ask or we want to figure out your total distance traveled, that is 10 plus 10 is equals to 20 steps. Okay. Now, to further understand distance and the concept of distance traveled, let's look at this illustration and this problem. So as you can see here, we have this map showing the distances of each places together between each other. Then this is the problem. So you have planned a fun day to spend the day. From your house, you wanted to go to the market. Okay. Then from the market, what you wanted to do in the market is to buy a gift for a friend. After doing so, you are invited to enjoy your time in the amusement park. So what is the total distance traveled by you? So to solve this, we have to put the given first. So to identify the given, so again, what we wanted to do is to um, note the given. So first two givens should be D1, your house to the market, because you went from your house to the market. So that is 120 meters as based from the diagram. Then from the market to the amusement park, that is another 60 meters. So to solve that, distance traveled is equals to total distances traveled, or the chunks of the places that you go through, then add those things up. So we have D1 plus D2, so that is equal to 120 meters plus 60 meters, and that is equal to 180 meters. So this is the answer for this problem. However, if we are asked another worded problem about if we are from the amusement park at that point in time and we thought of going to the park, then from the park we went back to the amusement park, then finally we went home after spending such a fun day, what is then the total distance traveled by you for this whole day? Okay, so take note that we are now talking about the total distance traveled for the whole day. So you have to take note of the initial distance that you've had. Okay, so that would be 180 meters from the previous problem. Distance 2 would be 50 meters, amusement park to the park. Then from the park to the amusement park, you have 50 meters again. Then amusement park going back to your house, that is 60 meters. Now to solve this, you just have to put the solution. So again, that is total distances traveled. That is equals to D1 plus D2 plus D3 plus D4, or summation of all distances, is equals to 340 meters. Okay, so in solving our problems, you can always pause the video and try it yourself, then just play the video to see the solution of the problems. Next would be this problem. So as you can see, this is a very wordy problem. You can pause the video to read this. So while reading through the problem, we know that this is kind of wordy, so we can chunk it down into two parts. So the first part would be this. So you and your friend are figuring out the path with the shortest distance traveled between your school to the arcade. So with you, your distance traveled are as follows. So first, 50 meters north to the market, then 5 meters east to the bus terminal, then 60 meters south from the bus terminal to the arcade. So take note that even if there are distances or directions, even if there are directions like north, east, south, we don't take that into account because we are talking about distance. Alright, so you can just ignore that in this problem, right? Now to solve that, again, we just have to add all of those values. So we have 50 meters plus 5 plus 60, we have 115 meters. However, we are not yet finished because this is just the first part of the problem. We still have the second part. Now, for the second part, we also have to take note of their distance traveled, or their what they have traveled so far. So first, 5 meters west, then 30 meters northeast, then 30 meters south, then another 10 meters south. Okay? So you have to thoroughly read the problem in order to get all of the given values in the problem. With that, we just solve it. So just get the summation of all the values and we get 75 meters. However, again, this is not yet finished. We have to still get or answer which of you took the shortest distance traveled. And since 115 meters is greater than 75, your friend took the shortest distance traveled. Okay, I hope you get that. I hope that you were able to absorb everything that has happened. Now, to clear misconceptions, sometimes we say distance traveled, and take note that these things are different from each other. So sometimes distance and distance traveled are used incorrectly. When we say distance, it is just concerned with the magnitude of the space between two positions. For example, we have the amusement park and we have your house. So the distance between those two would be 60 meters. However, when we say distance traveled, this refers to the of the path between total length of the path they took between two positions or to go into position A from position B. So for example, from your house, you went to the market. But what you did was you went to the amusement park first, then you went to the park, you went to the amusement park, then you went to the market. So you have to add all of those distances or all of those length of paths in order to get your total distance traveled. All right, so that's how we take note of those kinds of things. All right, next would be about distance traveled and displacement or distance. So when we say distance traveled, again, this takes note of every length of path that you took to go from position A to position B. While displacement is only concerned with the shortest path that you need to take to go from position A to position B. Now, to fully understand that, let's take a look at this. So again, from distance, let us now talk about displacement. Now, this might create confusion at first, but just stay through and let's go through this together. Alright? So displacement, again, refers to the shortest distance between the object's final position. So when you go to your house or when you're from your house, then go to the store, your displacement is also the same. That is 10 steps. But when you go back to your house from the store, your displacement from your house is 0, right? This is because your initial position is the same with your final position. So the um, the shortest distance between those positions is 0. Okay, now going back to our previous examples, all right? So when you were planning a fun day, what is your displacement at the first part of your day? So again, from your house to the market, then from the market to the amusement park, what is your displacement? To solve this, we will just need to again identify the values that were mentioned in the problem. Then for the solution, so displacement, and it will be D1 minus D2. This is because when you went to the market, you are going farther away from your house. But when you went from the market to the amusement park, you are going nearer or that you are going towards your house. That's why we know that your displacement is not widening, but it is getting smaller as you go towards your house or as you go back to the amusement park. So that is 60 meters. However, we can also look at the illustration, right? So in this illustration, as you can see, since you are in the amusement park and we are asking about your displacement, since it is 60 meters away from your house, therefore your displacement is 60 meters as well because you are 60 meters away from your house. Okay, I hope that's clear. Now, for the second part of the problem, when we were asking about your displacement in reference to your house when you came back to your house, right? Because the um you went to the park, then went back to the amusement park, then finally went home. So the answer here would be 0. All right? So your displacement is equal to 0 because your initial position or your house is also your final position, which is your house. Alright? Now let's try this another problem. You can pause the video to solve this. There. So a bus travels along a straight road 100 meters east, then 20 meters west. So what is the displacement of the bus? So let's look at the given. So we have D1 100 meters east, D2 20 meters west. So to solve this, we will assign a negative value to the motion towards west direction, then positive value to the east direction, and also likewise to north and south, where we can refer this to like a Cartesian plane, right? So when we say Cartesian plane, the x-axis, the negative values are going to the left. The positive values are going to the right. Then the positive values and in the y-axis going up, and the negative value going down. Alright, so displacement is equal then to 100 meters minus 20 meters. Since we have used it, or we have assigned a negative value to it, then we get 80 meters. Right. However, this still misses a direction, and since the answer is positive, then we know that this is east, or this is found in the east of the initial position. We can also use the Cartesian plane to visualize this. So we can, when we talk about a Cartesian plane, it is a coordinate system where we can plot points with regard to the x-axis and y-axis. So in this scale, 1 point is equal to 10 meters. So this is 10, 20, 30, and so on and so forth. So for the first destination of the bus, it traveled 100 meters east. Then that's the point A. Then 20 meters west, which means that from point A, it traveled back. Alright? 2 steps back, or 2 points back. That is point B, or to west, right? So this means that since this is in point 8, therefore this is 80 meters west, because it is pointing at the west direction of the starting point. So the starting point is at point 0. Next example. So a jogger travels 4 meters east, then made a turn and traveled 3 meters north. From there, the jogger then traveled 4 meters west. What is the displacement of the jogger? So you can solve this through assigning values to each distances, but you can also just visualize this the way we did on the previous problem. So as you can see here, point A is the initial point. Point B would be the 4 meters east, because our scale is 1 point is equal to 1 meter. Point C is when the jogger traveled 3 meters north from point B. Then point D is traveling 4 meters west from point C. But as you can see here, when we were talking about displacement, we just need to figure out the distance of point A to point D. And because we can see in this visualization that the jogger is 3 meters north from its starting point. So therefore, that is its displacement. 3 meters north. Alright? So another way of describing displacement is the graph method. So in this displacement time method, each value corresponds to each value as well. So for example, displacement and time. So at time 0, the displacement is also 0 meters. 0 meter. At time 2, the displacement is 2 meters. At time 3, displacement is 1 meter, and so on and so forth. So we can see the intersections of the point or where the point is intersecting with. Okay. So from this table and this graph, what is the displacement of the object at 0 seconds? So just look at time, then find 0, then look at where it is intersecting. So that is 0 meters. How about at 4 seconds? So time 4 or 4s, 4 seconds, where it is intersecting, that is 0 displacement as well. So therefore, it is the same. So the question is, why is this so? This is because we can infer from this that the object went back to its starting position. Okay? Because the initial and final position are the same, or that the displacement is 0. I hope you were able to understand that the lesson. If you were not, you can always go back through our problem solving a while ago, or just go through the lesson as we go, as you figure out the distance and displacement lesson. Now, we can now follow through the answers to the pretest. So for this, you can now take back your books, your notebooks, put it back, check your answers, and you could also take note of the correct answers, or you can solve it again. So for question 1, the answer here is displacement, because we are talking about how far is Sandy from her initial position, and since Sandy traveled through the problem, we cannot say that this is her distance or distance traveled. Number 2 would be 100 meters. As you can see again in the illustration, your house to the beach is 100 meters. And also this is the same with your displacement, it is 100 meters. For question number 4, your distance traveled is 160 because you went to the house. You went to the beach from your house, then from the beach you went to the market. That is 160 meters. In question number 5, so since we are talking about displacement, the answer here would be 40 meters because as you can see from the diagram, you're 40 meters away from your house. Okay, and you can also solve this. So this is 100 minus 60, that is 40. So just to recap, again, distance refers to the length of path taken by the object from its initial to its final position. So it takes into account all of the places that you went through before you arrive to your final destination. While displacement, this just refers to the shortest distance between the object's initial and final position. So even if you went zigzag, you went through different paths and all that, it is just taking into account position A and position B. That's why we are not concerned with that. We are just concerned with the shortest distance between A and B. All right. So with that, we have this challenge question. So a jogger travels 4 meters east, then made a turn and traveled 3 meters north. From there, the jogger then traveled 4 meters west. What is the total distance traveled by the jogger? So you can input your answers in the comments section of PhilSciHub Facebook post about this module, and I hope to see your answers there. All right, but also you can answer these assessments that will be given by your teacher designed for this topic. So I hope you answer all the assessments to develop a deeper understanding of distance and displacement. So we have distancia or distanya, X's and Y's, to this tour guide, explorer's log, and ilugar mo. So I hope you had a fruitful learning. You can visit PhilSciHub's social media accounts to learn more. So we have www.philscihub.com Also in YouTube, PhilSciHub TV, in Twitter, Instagram, TikTok, and Facebook at PhilSciHub. And I hope to see you more next meeting. So we have these references, and I'm also asking you to please evaluate this module through this link, tinyurl.com/fsheval, or through scanning the QR code above for easy access. So again, thank you so much, and I hope you learned a lot from this session. See you!